Hi, this is Rifa Sultan. In this video, I'll be showing my AI behavior system project. The system is built entirely in C++ without using Unreal Behavior Tree, and it focuses on four main states: patrol, detect, chase, and flee. Um, this diagram shows the logic of the AI state machine. The AI starts in patrol, walking between waypoints, and might randomly stop and start rotating to scan the environment. And if the player is in range, it will then switch to detect mode. And if player is close enough, then it will start chasing. Here you can see the patrol state in action. The AI moves along slowly, and there is a 50% chance it stops like every 10 seconds to rest. And during this time, it slowly rotates to scan the surroundings. And here, as you can see, the player enters the AI's detection range, and the AI immediately faces the player and starts tracking them using pawn sensing. Even if the player moves around, the AI keeps its orientation towards the player until the player breaks line of sight. Um, Before we move to the chase behaviors, here's a quick look at how the system transitions. So once the AI detects the player and confirms it's within the chase range, it seamlessly switches from detect to chase, prioritizing pursuit over idle scanning. Here's the AI actively chasing the player. It follows the navigation path, adjusts its facing direction, and starts shooting when close enough. If the player hides, the AI heads toward the last known location before returning to its routine. After a chase, the AI can dynamically react to danger. So when its health falls below 50%, it prioritizes survival. This sets up the next clip where the enemy retreats instead of fighting to the death. In this demo, you can see that once the AI drops below 50% health, it quickly backs away from the player. If it later recovers or loses sight of the threat, it smoothly returns back to detect or patrol. And this is the core logic behind the AI behavior system. Instead of relying on the built-in behavior trees, I designed a simple but flexible C++ state machine that controls pretty much every reaction. Here, the handle resting function controls when the enemy poses and performs a 360-degree rotation. It uses random intervals, so the rest moments feels more natural instead of predictable. So this small details helps make the pattern look more lifelike. And once the player enters the detection range, tick detect makes the enemy immediately face the player and update the last known position. So this ensures that even if the player hides, the AI still knows where it was last seen, ready to transition into a chase. And in tick chase, the AI actively pursues the player. When it gets close enough, it stops and fires, but only after a short cooldown. That cooldown is to prevent spam shooting and gives the combat rhythm and pacing that feels more human. Finally, like all of this is managed by the main tick function, the decision hub. It constantly checks visibility, distance, and health. When health drops below 50%, it instantly switches to flee mode. Um, so that when the player is lost, it returns back to the normal state. So this gives the system adaptability across every situation. So the whole system is designed to make the AI feel more alive, alert, responsive, and able to make different decisions based on context, health, and visibility. In the next stage, we're planning to connect this with the PCG module. Uh, Procedure generation will define patrol paths, spawn points, and safe zones. So the AI will automatically use this for its patrol and flee behaviors, creating an adaptive and scalable system. And yeah, that's it. For the final project, we're considering adding like even more behaviors, maybe cover mechanics or group coordination. Uh, we'll see how far we can take it. Thanks for watching.